Welcome. Today we're talking about what it means for polygons to be similar. The textbook definition of similar says that two geometric figures are similar figures if and only if there is a similarity transformation that maps one figure onto the other. Now this is an overly complicated definition, but my biggest issue with it is that we're defining similar figures using the phrase similarity transformation. If you don't know what similar figures are, how are you supposed to know what a similarity transformation is? So basically, similarity transformations involve dilations. You can have a dilation alone or a dilation plus a congruence transformation. Here is a parallelogram. A dilation is a transformation that basically just stretches out the object. And then we could add a congruence transformation such as a rotation or even a reflection or a translation. From where we started to where we finished, those are similar figures. Basically, these shapes are made bigger or smaller using a constant scale factor. That's the dilation. But this leaves the angles the same as they were, and your sides end up proportional to the original. Today we're focusing on the angles staying the same. On our next video, we'll look at the sides being proportional. Let's test out how to find if figures are similar. First, we'll check the angles to make sure they each have a corresponding congruent angle in the second figure. And you'll see as these angles bounce around the pentagon, yes, they all have a match. Now we need to check the sides. We do have more on this in the next video, but basically what we're looking for is, does the relationship between the side lengths stay consistent between the figures? Now in the first figure, all of our sides are congruent. In the second figure, all of our sides are congruent. So yes, the relationship does stay the same. So we have similar figures. Triangles are a special case because they only have 3 sides. As long as the angles are all the same, the triangles will be similar. Basically, you can't get the angles out of order in a triangle like you could in other shapes. Now, similarity statements are just like congruence statements in that the corresponding parts have to match up in the right order. So, for example, the 40-degree angles, the 65-degree angles, the 75-degree angles, they all have to match up. So if we name the first triangle ABC, then we try to write a similarity statement between the two triangles. Since the first name starts with A, we look at angle A, which is 40 degrees. Then we find the 40-degree angle in the other triangle, and we realize that's at angle E. So when we name this triangle, we're going to start with E. The second letter in our first triangle name is B. So we'll find angle B, that's 65 degrees. We'll look to the other triangle, find the other 65-degree angle. That's angle F, so F will be the second letter we use. And then C, last but not least, 75-degree angle. So we'll find the 75-degree angle in the other triangle, and it's angle D. So D is our third letter. Now I want you to try this one yourself. We have irregular pentagons here, but I'd like you to try and finish out the similarity statement. Pause the video. The first one is A, B, C, D, E. Remember to look for the matching angle measures and go in that same order. So if we start with A, then H is the matching 115-degree angle. B is the next one. B is 85, which means G is our next letter. Then the third one, C, is 120, so we go to F. And if you notice, our letters are going around counterclockwise here. And since the letters in the other one went around in order, these will continue to go in order, and we can finish out our name with J and I. Now here's a bonus question. Knowing that those corresponding angles are congruent, how big is angle J? J was blank here on our polygon, but we know J is the 4th letter in the name, just like D is the 4th letter in the name. So if angle D was 95, then J is 95 also. Now here's another one to try. This one, we already have a similarity statement for the two quadrilaterals, but we need to see if it's true. The first thing we do to see if this similarity statement is true is check the angles. So angle A is 85, that should correspond with angle J, 85. Angle B is 115, should correspond with angle K, also 115. Angle C is 115, which should correspond with angle L, but angle L is 85. They don't match. The corresponding letters in the names are not congruent angles, so no, these are not similar polygons. Here's another one to try. Are these triangles similar? If they are, we're going to write a similarity statement for them. Now, one of the things you might notice is that there's only one number in each triangle. Those numbers are the same, but there's only one. Now, if you notice, though, they are both right triangles, so we really know two of the angles. So let's focus on triangle ABC for a moment. If we look at the 90-degree angle and the 50-degree angle, we can find angle B. 50 plus 90 is 140. 180 minus 140 is 40, so angle B is 40 degrees. Let's focus on triangle FGH then, and let's see what happens there. We have a 50-degree angle and a 90-degree angle again, so 140. 180 minus 140 gives us 40, so angle F is also 40 degrees. So yes, all three pairs of angles are congruent, so the triangles are similar. Now our similarity statement, though, we can't necessarily use the same name that we gave triangle FGH. That was just a random, I see a triangle, let's give it a name. You can use any order for the three letters. If I want a similarity statement, remember they have to go in the correct order so that the corresponding angles match. So if I keep my ABC for the first one, A was the right angle, so we'll need to start with G in the second triangle because it's the right angle there. Triangle ABC is similar to triangle GFH. Now this leads us to something that's kind of nice and makes triangles really easy to see if they're similar. It's called the AA similarity postulate. It's kind of similar to the congruence shortcuts that you might have used earlier in your year of geometry. This says that two triangles need only have two sets of congruent angles to prove that they're similar, because the third angle theorem says that if the first two angles match, the third one has to. And then we have all three matching. That's all for today. Thank you for joining me, and I'll see you soon.